Okay, let's go ahead and get started on today's lesson. Today we're going to dive into square roots and perfect squares. So by the end of it, you should be able to say that you can evaluate square roots and perfect squares. Okay, just to look at some vocabulary, a perfect square is going to be the square of any integer. And so our perfect squares, just the first few are going to be 1, 4, 9, 16, 25, 36, 49, 64, and 81. I'll show you here in a second how we get those perfect squares. And then the square root is going to be the opposite of those perfect squares. And so what we're going to do to get the perfect squares, here, let me write the first ones out. 1, 4, 9, 16, 25, 36. The way we get these is we take all of our first whole numbers or integers, like 1, 2, 3, 4, 5, 6. We take those integers and we're going to square them. It's the square of each one of these. And remember, to the second power means that not that you're going to take 5 times 2, but instead you're going to take 5 times 5. So we do that and we get 1 times 1 gives us 1, which is our first perfect square. 2 times 2 gives us 4. 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, 6 times 6, 36. And this just keeps going on forever. Okay? Now, I know you've had perfect squares in the past, but you might not have looked at perfect squares as far as being integers, the square of the integers as well, because the same thing works for our negative versions of this. Whoops. If you look at negative 1 to the second power, you're going to get negative 1 times negative 1, which gives us a positive 1. Same thing for negative 2 to the second power is negative 2 times negative 2 gives us 4. And so it does work for integers, not just whole numbers, but integers. It's going to be any of these counting numbers and their opposites, because since you're multiplying it by itself and there'll be 2 negatives, it will give us a positive. So our perfect squares are going to be these numbers right here. And this is how we get to our perfect squares, by simply taking our numbers and squaring them. When we're finding the square root of a number, what we're doing is we're trying to figure out, and for what we're doing today, we're going to try to figure out, most of them are going to be our perfect squares like this. We're going to try to figure out what number times itself gives us 16. Okay? So the trick here is there's only one number that can fit into both of these, and that number has to be the same, okay? And then when you multiply them together, they have to get 16. So for example, if I put a 2 and an 8 in here, it's true that 2 times 8 gives me 16. However, because 2 and 8 are not the same, then we're kind of going against the rules of square roots. We're looking for pretty much what perfect square fits in here. And so the answer then would be 4 and 4, because 4 times 4 gives us 16. So we pull one of those out, and the square root of 16 is 4. Another way to think of square root is just simply being the opposite of squaring a number. Because if I do the square root of 4 squared, we get 4. And so just like the opposite of multiplication is division, the opposite of addition is subtraction, the opposite of squaring a number is taking the square root of the number. So let's do some square roots. We're asking ourselves, what number times itself gives us 64? And so if you would like to use your calculator, you come over here and you type in 8 times 8. And we found out that 8 is the perfect square. For tonight's homework, I'd like you to try to avoid using the calculator at all if you're going to use the calculator, simply use it to double check your answers, which is what I'll do from here. So we find that 8 times 8 is indeed 64, so we pull 1 out, and 8, the square root of 64, equals 8. This one has a negative on the outside, but then the square root of 4. What I want you to do is ignore that negative to start off with, and simply find out what times what gives us 4. And that'll be 2 times 2. So we pull 1 out, we get, whoops, I wrote an 8, but we get 2. Now we have to go back and look at that negative and tack it on. So negative 2 is the answer. So negative square root 4 equals negative 2. Same thing here, negative square root 121. We're trying to figure out what number times itself gives us 121. So we can try something like 8. But then we remember 8 times 8 is 64, so we need something a little bit bigger. Let's try 10. If we type in 10 times 10, you'll see that it equals 100, so we're not quite there. Let's try 11 maybe. 11 times 11, and we get 121. So we found out that 11, or the square root of 121, equals 11. Don't forget about that it was a negative, so we'll tack that on, and we're good. So again, we're using the calculator to simply help us find this 121. I don't want you to just type in square root 121. You need to understand the process. So now we look at square root 525. Again, we're looking for a number. I'm going to say 20 times 20, and that gives us 400. So 20 is not big enough. Let's do 30 times 30. That gives us 900, which is too big. So let's try going in the middle there. 25 times 25, and that gives us 625, which there's actually a typo. This should be 625. Go ahead and make that correction. So the square root of 625 is going to give us 25. On fractions, think of it as this: the square root of 4 over the square root of 9. These are equal to each other. Now we simply have to find the square root of 4, which we've already done, is 2. And then the square root of 9, we ask ourselves what times what equals 9. And that one is 3. And so 2/3 would be our answer. Okay. Now I want you to determine if these are perfect squares. This one works out to be real nice because if we take, is there a number, basically what we're trying to find is there a number that if we times it by itself gives us 9/4? And if we take 3 halves times 3 halves, isn't that taking it times it by itself? Which is very good. 3 halves times 3 halves equals 9/4. The only problem is that if we look back here, the definition says the square of an integer. A fraction like 3 halves is actually a rational number, not an integer. So we're going to say that this is not a perfect square. -4, this one's a little tricky because you would think 2 and 2, but that would give us a +4. So if we make one of them negative, that does give us -4. However, because -2 and +2 are not the same, it's not a perfect square either. At 16, we have 4 and 4. They're the same number, so that is a perfect square. And 111, there's the only ones that I know of, be 11 and 10, and that will not give us, but since they're not the same number, it's not a perfect square. So 16 is the only one. Okay, that's your perfect squares. Come ready to work tomorrow, and we'll answer any questions.